Good evening, everyone. Hear me? Can you hear me now? Hello? Good, thanks. Welcome, everyone, to the WinHUGR meeting for December. Our agenda for tonight, to start on time, which we almost did. A few quick announcements. We have a member report. Good evening, everyone. An experience from Unite 2016. We have a micro talk on a product that made it into the store. Actually, was in the store in a number of other forms. And welcome everyone to the WinHUGR meeting for December. Who's going to share his experience there. Our main presentation is by Joe tonight, and he's going to talk start until time, which will be 3D audio. A few quick announcements. We have a member report. We have door prizes and refreshments and experience from Unite. So please stick around after the main presentation. We have a micro talk on a product that made it. So since we met last month, a couple of things have come up that I think is important to share with everyone. Welcome everyone to the HoloLens companion kit that is going to release to share his experience. What's inside that? Our main presentation is by Joe tonight. If interested in talk start to holographic remote audio. A few quick announcements. We have a report. We have door prizes and experience from Unite. So please stick around after the main presentation. We have a micro talk. That's a demo that will allow you to create your own. So since we met last month, a couple of things have come up that I think is important to share with everyone. Welcome everyone to the HoloLens companion kit that is going to release to share his experience. What's next? Our main presentation by Project. I haven't had a chance to talk about the holographic about using audio. A few quick announcements. We have a report. We have door prizes and experience and advice. So that's a demo that will allow you to create your own. So since we met last month, a couple of things have come up that I think is important to share with everyone. Welcome everyone to the HoloLens companion kit that is going to release to share his experience. What's next? Our main presentation is by Project. I haven't had a chance to talk about the holographic about using audio. We have a report. We have door prizes and experience and advice. So two big things now happen. That's a demo that will allow you to create your own. So since we met last platform, a couple of Intel creating that reference design platform for HoloLens companion VR to share his experience. What's next? Our main presentation is by Project. I haven't had a chance to talk about the holographic about using audio. We have a report. We have door prizes and experience and advice. So two big things now happen. That's a demo that will allow you to create your own. So since we met last platform, a couple of Intel creating that reference design platform for HoloLens companion VR. The creators of the share last experience. What's next? Our main presentation is by Project. I haven't had a chance to talk about the holographic about using audio. We have a report. We have door prizes and experience and advice. So two big things now happen. That's a demo that will allow you to create experience. So since we met last platform, a couple of Intel concept of it mixed in. They'll have, I don't know if it'll be real sensor or HoloLens-based sensors, but there'll be sensors on the device, creating another type of mixed AR experience. And very little has been said about what these guys are going to release, other than one starting at $299 and the word accessories have been announced. So you can imagine there's going to be a range of devices, and that may also mean that some of these guys are looking at perhaps the Intel reference design, who knows. But big news for us, because that means besides AR apps, our group is going to be heavily into VR devices and everything else on Windows holographic platform. So from the beginning, that was the intent of the group. Microsoft said that it was a platform, and then HoloLens was the first device. So we now have announcements that make us believe we're going to have a whole bunch of other devices to create experiences on coming up. Also, since we last met Unite 16, Unity conference has happened, but since we have somebody telling you about his experience there, I won't get into any details specifically on that for now. We'll just use that as an intro to roll over into Matt's talk. So Matt Bielman, I'll give you the mic and the clicker, and I'll go sit.
Thank you, sir.
Your slide deck is active.
All right, so I'm Matt Bielman. I spent last week at Unite, which was in Hollywood. This time it travels around. There's a Unite in the US, there's one in Europe, moves around quite a bit. A little bit about myself while slides are coming up. I have one HoloLens app published in the store called HoloBlocks that was kicked out over the summer. I'm an independent developer when it comes to HoloLens. I do this in my free time. Full disclosure, I'm also a Microsoft employee, but I don't have any connection with HoloLens. I went to Unite on my own dime as an enthusiast and someone that's interested in learning more. So I'm going to give you a quick debrief of what I saw there specifically from sort of a HoloLens point of view. See if we can get this to go. So while this is coming up, Unite is Unity's developer conference. This is my first one that I've attended in person. I've watched it on YouTube quite a bit, watched the videos that get posted. It is quite a bit larger than I was expecting attending there in person. The number of users and companies that are using Unity is pretty astonishing in all kinds of different fields. It's heavily skewed towards game developers, but you see folks doing medical training, all kinds of different projects from AAA games to retail kiosks, everything in between. Hey, there we go. So this particular one was about a week-long session. They also do training. You can get certified there. I opted not to do that this time around. Hundreds and hundreds of people across all sorts of different roles: developers, designers, artists, audio, everything. You can see a couple of the other things up here. There's an award show, training, like I said, showcases, so much more. There's too much to both take in as an individual and report out to you guys. So I'm just going to give you sort of a taste of what I saw and some of my key takeaways. So attending in person is something I would recommend if you can swing it. These are just some photos I took while I was there. For two main reasons that I want to talk to you about. So first one is, while a lot of what happens at Unite makes it up on YouTube is a video and you can go watch sessions for free, there does seem to be quite a bit of a delay between when the event happens and when those videos come out. They sort of trickle out over time. So going in person, you get this information immediately. It's quite useful. And also you have access to the people in the community, which I think is even more important. Like I said, you have folks ranging from sort of armies of one that do everything, that are their own individual shops, to AAA game developers. I found everyone to be, incredibly accessible if you wanted to talk and ask questions. They're very interested in engaging with folks. So it's a fantastic networking opportunity, and that's really the second one. With this group in particular, if you're working on HoloLens, I had my device with me, lots of interest, lots of questions came my way around, people are aware of HoloLens, but maybe not necessarily have seen one. So it was a great opportunity to meet people that were interested in talking to a HoloLens developer and understanding what it takes, or how to connect with folks. It's also particularly fun to sort of grief people with putting holograms on the stage while they're doing their talk, and that was a fun thing to do that you can only do with HoloLens right now. So I took about 18 sessions or so while I was there. It was a full day. It was 9 to 5 every day, back-to-back sessions. Like I said, there's just too much. There's no way to encompass everything. I went specifically with a focus on things that seem pertinent to HoloLens. I expect that over time these sessions will trickle out and you'll be able to see them on YouTube. The keynote is available right now. I would recommend everybody watch that. It's a great overview of what happens at Unite as well as what's going on with Unity. There wasn't anything specifically around HoloLens there, but they had some fantastic demos and showcased some features that are pertinent to HoloLens but not specific for it. The roadmap session goes a little bit more in depth into what's coming, and I'll cover some of the highlights from each of these that are relative to what we're talking about. The mixed reality scenarios on HoloLens was put on by Microsoft. That was a great introduction to what HoloLens is about. Some of the content from that was actually shared here, I think, last month, or maybe the month before. around best practices for design, how to get started, what content is available through the Holographic Academy on the YouTube channel, and so on. So these two, this and the multiplayer, for folks that maybe aren't necessarily developers but are interested in Windows Holographic and how to design for it, I would recommend these when they become available. The networking one in particular, networking and multiplayer across HoloLens, is a hot topic. This doesn't go necessarily into code and how to go build, but has a lot of interesting design concepts on how to think about what kind of multiplayer infrastructure works best for different scenarios, and some examples of that. This was put on by the folks that create Homeworld, which is a big real-time strategy game, which is very interesting talk. For the developers in the audience, the real-world HoloLens development and the performance talk in particular were huge key takeaways for me. The HoloLens development with Unity has a fantastic demo of the holographic remoting app, and using that to iterate much quicker in the 5.5 beta. So if you haven't seen that, or you want to see more about how that gets done, this is one to watch out for. The performance one in particular, though, this was the most profound session for me as a developer, because eking out every last bit of performance you can on the HoloLens is a worthwhile endeavor, because you get to do more. This was a follow-up to a Unite 15 talk that is on YouTube. The Unite 15 talk covered memory management and using the profiler and some basic stuff. This is the next version of that, the next step, and had a lot of good information on how to optimize animations, loading scenes and shaders and everything as fast as you possibly can, reducing lag. Fantastic talk. I have pages and pages of notes out of this, so if you're interested or thinking about performance issues, come talk to me and we'll chat, because I could spend an hour talking about that topic in particular. So some major key takeaways that across the sessions. One is Unity Connect. If you watch the keynote, you'll see a little bit about this. This is essentially a networking website, so it's connect.unity.com. The reason I bring it up with this audience is that many of the folks in this group have some unique experience working with HoloLens, and it's not that common of a thing yet. So if you're somebody that's interested in hooking up with a studio or looking for work, and you have expertise on HoloLens that you want to market, go sign up here, put HoloLens, Windows Holographic, AR, all that stuff that you do as a skill. Put your projects up here. It's a great place to go meet folks that might be looking for either a developer or an artist or whatever. So that's particularly useful. The iteration on the device, this is the remoting thing that was mentioned earlier. So that was shown. That's a major thing that's available now. The next one is something that I'm particularly excited about but haven't had time to investigate yet, which is in the experimental branch of Unity, there is a new set of code to do dynamic nav meshes. So if you're not familiar with nav meshes, this is how you would have AI running around in a scene. Normally that gets baked when you're building your game, which for HoloLens, if you wanted to have characters running around this room on the spatial mapping mesh, is not an option. This lets you theoretically do that at runtime. So I would love to see someone pick this up and get proof of concept going with this on a HoloLens and see how it works. This is super exciting for a bunch of different scenarios. Some interesting things that were talked about that are coming in the future, date not necessarily specified. 360 video player. So if you're thinking about doing something along the lines of HoloTours where you want a immersive video, that is coming as essentially a new video player for Unity, where you just drop it in, drop a 4K video in, and hit play. So doing 360 video scenarios will become immensely simplified in the future. Another thing that was shown during the mixed reality scenario talk was a new rig for doing mixed reality capture from a spectator point of view. So not necessarily first person from your own HoloLens, but a second device that essentially was mounted on a DSLR camera. So I wasn't able to capture a picture of this. It went by a little bit too quickly for me to grab. But this is essentially a open source hardware and software sort of piece. So you can 3D print the rig, download the source from Git once it's up there, and have a higher quality mixed reality capture. I'm super excited about that. Lastly, super nerdy in the weeds stuff for performance was optimizations around the transform component in Unity. If you've tried having a scene with 10,000 game objects in it and moving them around, you notice that blows up pretty quickly in terms of performance. All of that's getting optimized and rewritten. So for us in particular, where we have some performance, where performance is a key consideration, this is going to be a huge sort of for free performance bump that you get if you have a complex scene. So that's it. Those are sort of key takeaways. Here's some resources. Like I said, videos, youtube.com/unity3d. That's where they appear. So I would recommend subscribing to that. You'll see them as they pop out. Rest of the pertinent stuff from sessions that I could capture are up there. If you have any questions, you want to learn more about a particular thing, come talk to me afterwards, and be happy to fill you in with what I can. Thanks.
Thank you, Matt. Next up, we have Yoon, also from Microsoft, but I'll let him explain. He's speaking about a personal project of his own. Careful as you step through there. I'm going to hand Yoon the mic and put up his slide deck. Here's a clicker.
Hi, I'm Yoon, a designer and developer. It's really great to be here today. Thank you very much, Dwayne and Mike, for inviting me to this awesome event. So today, I want to talk about my journey on designing and developing this app called Typography Insight for HoloLens, which has been published to the store several weeks ago. So quick background, I was a software engineer a while ago, but I went back to design school to study graphic design. So I fell in love with typography. Then, so with this, my mixed background, I've been creating a lot of iOS apps for a while. But recently, I also started learning Unity to create the HoloLens apps a few months ago. And also, currently, I'm working as a UX designer at Microsoft and HoloLens team. But this presentation will be about my personal project and as an indie developer's perspective. And all opinions will be my own. So Typography Insight is a kind of toolkit for learning and teaching typefaces. So I have published this app about 5 years ago and on iPad, and it's been featured on App Store several times. So with this app, you can learn about basic terminologies and how historically important typefaces has been evolved. And you can observe the details of the typefaces in very large scale, and also compare two different types in multiple different ways by overlaying or side-by-side comparison. So it was kind of new way of interacting with types on leveraging this kind of new touch interface on iPad. So this was kind of 5 years ago. Yeah, and it was introduced by some of the magazines like Fast Company and The Atlantic, and has features like typeface anatomy, historically important typefaces, and some inspector. You can observe very large scale the detailed shapes of the types, and also some of the different way to compare the details of types. Then early this year, I found this solution called Windows Bridge for iOS, the project Islandwood. And fortunately, I was a lead designer for this project in my company. And so personally, I also use this project solution to bring my apps to Windows. So now the app is running on Windows using exactly same Objective-C code, but as a UWP app. So this was like last June, and we also presented this as an example of that Windows Bridge for iOS at Build conference. Then I met HoloLens, and I started thinking about my apps, and from 2D world, So these are some of my apps for games and the game for kids, and started thinking about what kind of apps can be better in 3D world. And so initially I chose this app called Pori Fashion Show. I made this game for kids with my wife. So basically, it's kind of paper doll style game. You can drag and drop different types of clothes and skirts, pants, and create your own character and save out them, and you can run your own fashion show. So this character is actually my wife. I was drawing my wife as a cartoon character. So yeah, you can save out your own character and run your own fashion show. So you can imagine how this could be translated into 3D world. So I started learning Unity and also started using the Holographic Academy samples and origami project. Learning the basic concept like a rigid body, animator, and collider. Then I also started using the simulator, HoloLens simulator. And this is kind of early prototype. I started learning how to use the force to move some characters and also playing with the physics from HoloLens simulator. So this was a kind of early prototype. And so next one is a more evolved version. I use the origami example with the combination with the other code to use the tap gesture and use it as a destination point and make the character walk toward that destination. So you see that cursor is coming from Holographic Academy sample. So then I started thinking about this typography app. How can I bring this app to HoloLens? And also I started looking at all these publicly available resources like HoloToolkit, the Galaxy Explorer, and the Academy samples. But the Galaxy Explorer was somewhat complex for me as a beginner. It was hard to extract the things that I want to achieve. But initially I used the whole Galaxy Explorer as just an example. I really wanted to put some simple PNG images in the space, but I didn't know how to do that. So I used the Galaxy Explorer. As you can see, there's a moon there. And this is a PNG images, but I realized that the types in space look so gorgeous. Yeah, you see the moon. I couldn't remove this moon in the Galaxy Explorer. It's generating lots of errors. But then I decided to use this origami as a basis of my project because it covered all these basic elements like a gaze cursor and gestures and voice and spatial sound and spatial mapping. And also I thought the tap to place feature is quite nice. Maybe I can use that to place the types in the space. Then I also started thinking about what's the design goal of my app, and I really want to help people experiment and play with types in space. And also, I was thinking about maybe this app could be used as a kind of reference toolkit in the future that designers and developers can just play with types in different sizes and colors and distance. Then I started sketching out the ideas. Then, as you can see, I was imagining using the spatial mapping and projecting the types on the floors and the walls, and also on the bottom left you can see the early sketches of the UI for type playground. And this is a sketch for the main menu. Then I started playing with actually putting the types in the space. Also started thinking about how can I construct the UI to select the different fonts for other menus. And definitely this simulator was really helpful for me to iterate this design, especially for this kind of UI. Then also, yeah, I started playing with the tag along and the billboarding concept, which is kind of important to build floating UI in HoloLens. And also, I started studying the concept of the box collider and also animator to trigger kind of secondary menu using the animation. And also, I used the cursors from one of the Holographic Academy sample. I think it was astronaut example. And yeah, then I started playing with the spatial mapping, even outside, also started playing with the different location of that, the main menu button. How can I define the distance to that menu? Then this is a kind of the first version of the app. I did this mixed reality capture in Bellevue Elements building. I thought the space was so beautiful, so I thought it would be a nice place to play with this spatial type. So basically, you can use your hand gesture to move around types, and of course, you can edit. So I'm going to talk about this a little bit later, but currently, this system keyboard is only supported by 2D XML view. So as you can see, once you invoke the keyboard, you're going to be popped out to the 2D mode, and once you finish the typing, then you're going to go back to 3D view. And this example was I was imagining maybe this can be used for maybe designing some architectural signage, or you can lay out the types in real time on surface. So you can imagine also maybe this could be used for maybe product design, like a package cover or book cover design. So you can lay out the types in, and you can change the different fonts and colors in real time and viewing that from the different angles. So in this first version, I didn't have that color picker option, but I'm going to show it later. And I had these other components, more learning components, like historically important typefaces, and you can open the details and learn about the descriptions and pangrams. One of the reasons I'm using the character G is that the G is kind of the most important character that shows the characteristic of the specific types. So yeah, this was a kind of first version. Then after publishing this video, I got really great response from design community. So it was introduced on Upload VR, and also John Maida tweeted about it. Then one day I went to Bellevue Art Museum, and I thought the space was so beautiful, so I wanted to do something with the hologram. And then I realized that maybe I can do something with types. So I have created the simple holographic type sculpture and placed it in this atrium of the Bellevue Art Museum. And so started playing with it, and I did this mixed reality capture. So as you can see, these kind of layered types are looking really gorgeous in this space, especially when there is a kind of architectural background over there. And when you actually experience this type in HoloLens, it's quite different from this video. In this video, the types are just shown as a white color, but actually when you try it on the device, it feels like glowing something like a neon. It feels quite magical. And also all these layered types looks gorgeous in device. So obviously, when I started adding too much things, it became super slow, but I was able to keep this kind of amount of the text here.
Is this recorded by HoloLens?
Yes, the mixed reality capture in HoloLens. And yeah, as you know, all the types are Helvetica, which has a really nice geometric form. And since I created this type sculpture with my app, still I was able to interact with it, manipulate it, even though I removed all the gaze cursor and UI, but it was kind of fun to play with. And I was imagining maybe in the future, we can think about more shared experience, and multiple visitors can collectively evolve this sculpture. This is an example of the rooftop garden. Of course, in actual device, it's kind of hard to see these types in the strong sunlight condition, but still, it looked really gorgeous in this background. So interestingly, it was very stable in this rooftop again. And you see these white dots are actually the raindrops. So this was my experiment on type sculpture, and I got also very interesting response, like unauthorized holographic sculpture placed in Belgrade Museum. And they were talking about, they're now talking about what's the future with this kind of digital graffiti, what's the privacy in shared space. And then I also continued adding the features. Now I added this color picker, and also I had this something called Typeface Explorer that I created about 10 years ago in Adobe Flash with Paper Vision 3D, which is a 3D engine for Flash. And I thought this would be also a good candidate for HoloLens. Now I can really use a 3D space. So this is a kind of result. So I have added this kind of three-dimensional timeline for the historically important types. Now you can scroll and navigate through this timeline, and also you can tap one of these items to observe the details of the large G shape, and also the description and the pangram. So I've been playing with this kind of form of this timeline, but it's very interesting. Now you can think about, now we had this kind of 2D list view in 2D world. Now you can imagine leveraging this three-dimensional space. We can really use this kind of three-dimensional space for visualizing data. And this example shows the color picker I have added in the latest version. So now you can change the color of the font in real time. And this spatial mapping is still very unstable. I'm just using one of the Holographic Academy sample, but it gives you very rough the surface. So I was not able to automatically align the types on the surface, but I really want to investigate the plane finder, which gives a developer more refine the shape of the walls and the floors. So currently, users have to align the types manually to the surface. And yeah, this example shows the types layer on the floor. And also, I have refined a little bit of the rotating interface, but all of these are coming from the Holographic Academy samples, the astronaut example that has a navigation and manipulation gesture. And in this example, I was playing with types on this elevator tower, and it was quite interesting. It was quite far, but I did this layout on the second floor, and then I moved down to first floor, but I was still able to grab it and interact with it. It was staying quite stable. So I can imagine the future of this kind of signage design without involving all this actual prototyping. So let me quickly go through these elements of the Typography Insight app. So of course, the text is kind of the most important element in my app. So I used UI text just to get the sharp text, but I'm going to talk a little bit about the details later. But I have this toolbar UI. So these are essentially a collection of the cubes, and I just layered over the PNG sprite images with the text. And also I use this Unity's animator to create this kind of secondary menus and with the animation trigger. And also I have, yeah, this is an example of a toolbar UI that invokes the secondary menus using that animation trigger. And I have these 3 different scenes in my apps, and I use that Unity's scene manager to load different scenes. And yeah, as I mentioned, I'm using the spatial mapping from the Holo Toolkit, the Academy sample. And also I'm using a lot of sprite images. These Gs are actually this PNG images, just like a hover and normal state. Just because I didn't know how to do this complex shader programming to get this effect. And other aspect is I cannot actually embed all this font file because of the licensing issue. So I just created the PNG images. Then gestures, yeah, as I mentioned, this is also coming from the Holographic Academy samples, the astronaut example. And text input, as I described, is quite interesting. You have to use the XAML in the build setting to invoke this assistant keyboard, and you're going to pop that to the 2D mode. And when you finish the interaction, you're going to go back to this 3D mode. So yeah, for the text in Unity, there are 2 components, a UI text and 3D text mesh. And in default, they are both very blurry. So Unity basically recommends for UI text, use this kind of dynamic pixels of a unit value higher than 10, or use this kind of scaling value. But I really wanted to figure out more accurate value that gives us more proper dimension that aligns with our existing type sizes, like in the Illustrator and Photoshop. So I did a quick, simple experiment. So I printed out this type ramp from Illustrator and placed on the wall. And from 2-meter distance, I used HoloLens and my typography insight and used my gesture to scale down the type size. And because I added this debug output, so I was able to get actual this scaling value. So this way, I could find, it's not going to be super accurate, but you're going to see, using this value, I was able to get the more proper dimension. So for UI text, in Canvas, UI text involves this Canvas container, so that you can use that scaling value 0.005 to get the proper dimension at 2-meter distance. And of course, you can use that dynamic pixels per unit value higher than to get the more sharper text. But if you increase too much, you're going to get more performance degrade. So you have to find the balance between the quality and performance. But for 3D text mesh, the scaling value is a little bit different. It's 0.005. Then you're going to get the more proper dimension from 2-meter distance. And also that will give you more higher rendering quality. Then this is a kind of example of the result using that scaling value on UI text and 3D text mesh. You can get now this. Now we can say 48-point type size on this 2-meter distance is similar to the existing sizes from Photoshop or Illustrator based on 2-meter distance. I heard that Unity UI text provides more detailed controls like alignment and in terms of UI, but I heard that in general 3D text is much more faster. So as for my next step, I'm currently working on save and load scenes. Currently, you can actually save out the load and the scenes, but I'm working on the XML or JSON serializing stuff, and also want to add more rich font libraries. So I'm looking at the open fonts options, and yeah, as I mentioned, I want to look into more plane finding and surface projection technology, and I'm also very interested in the animating types in 3D space in general. Yeah, thank you very much.
Thank you, Yoon. I should let everybody know that we do have Yoon's app on 2 HoloLens devices, our demo units. So afterwards, if you want to check it out, we can give you a peek at that. I'm going to help Joe quickly get set up here. Kind of rushed him through the beginning, and I don't know if he's had a chance to test his screen yet. One sec.
Let's turn it on.
You want to turn all the way up?
It's not letting me turn it on. There you go. They will just laugh at me if they're necessarily Christine?
Oh, that'll do it. Okay. Great. All right, so hi everyone. Thank you for coming out. My name is Joe Kelly. I'm an audio director at Microsoft for the Windows Apps teams. And I work on the central audio team for the experiences. So basically what we do is we kind of jumpstart a lot of the different studios, the different apps, and get them kind of up and running with sound. And basically the vast majority of my time over the past 2.5 years or so has been creating audio prototypes for HoloLens. And so we've learned like lots of things about kind of the best practices and all this stuff. I've done a few other talks before at different events, but a lot of them were kind of shorter or kind of set to different audiences. So I wanted to give a kind of more definitive, just all audio on HoloLens kind of all up talk. So we're going to start really basic with the hardware because I may not have to tell anybody here this, but I've gotten some interesting comments and questions about just audio on HoloLens. Everything from where are the speakers to how it's really cool that you drill the sound into our bones. I've heard that on multiple occasions. So I may not have to tell any of you this, but we don't do that. The speakers, there are 2 speakers on either side of the device. So if you do feel anything drilling into your bones, I recommend you see a doctor immediately. That's not us. So this basically gives us the ability to play stereo sound, which is the kind of the forefront of what brings us spatial sound. So it's super important to that. And you may notice that these are just small speakers that kind of sit outside of your ears. These are not headphones that are covering your ears or anything like that. Just like you can see through the device to be able to see the real world on top of your holograms, we want you to be able to also hear the real world. You may notice in kind of VR experiences can be pretty isolating. Once you put headphones on and you're hearing sounds in your VR experience, it's you end up with just not being able to hear people in the room. You can't talk to people. If you've ever demoed a VR experience, that might be a frustration for you. We try to give like the most mixed reality experience by being able to hear the real world and the app at the same time. And the source of a lot of controversy lately, we do in fact have a headphone jack. It is on the opposite side from the USB jack in there. So you can plug in headphones. We recommend, as a developer, I would recommend you don't create your experiences to be used specifically for headphones, especially if you're genuinely trying to create a mixed reality experience. Try to target the speakers, but it's good to keep in mind that your users can, if they're in like a noisier environment or they just want some privacy, you can plug in headphones to the device, and just any standard 3.5 millimeter headphones will work. And there are 4 microphones on the device. I chose this image because you can kind of see one, kind of a little bit to the bottom left of that little Microsoft logo on the device. It's just a little dot. So there are 2 microphones that are meant for voice capture. So they're kind of beamformed to the user's mouth so that they just don't get too much room noise. They don't get any of that. You can really get an isolated track of the user's voice. We use this for all the voice commands and things like that. And then there are ones on the outer side that are meant for the room capture. And these things are accessible to developers. The Holo Toolkit recently got a microphone stream plugin, and so you can choose to use that vocal stream, the user voice stream, or you can actually room capture, and you can do those captures inside of your app and even use them and process that sound to be used inside of your application. It's not just for mixed reality capture. You can do all kinds of stuff with it. And so one of the most important things that we have for audio and HoloLens is spatial sound. One of the kind of main goals just in general for HoloLens experiences is to be much more natural and just give the user like kind of a more human experience. You know, we try to really give like that 3D, really natural user experiences with visuals, and we do with audio as well. So just like you can see a hologram in your real world and it's really like locked to this location, we want to be able to do the same thing with sound so that you can hear things from all around you, and you can actually you can locate objects just by sound alone. Because just like in the real world, you can only see what's in front of you, but you can hear things in a complete 360-degree field. So if something is behind you and you can hear that and you can locate it, that's a really great way to draw user attention, all kinds of stuff, which I will get into briefly. But so spatial sound just in general is the idea that is just a processing that happens to a sound to make it sound like it's coming from outside of the user's head and not coming from the speakers that it's coming from. So if you're wearing headphones, for instance, and you have this sound coming from out here, we actually know what that sounds like when a sound is coming from out here rather than just coming from those headphones. And so we can actually do the processing that provides that delta between those two sounds, because sound doesn't just go directly into your ear canal. There are actually a lot of things that happen to sound before it reaches your ears. And we've measured all those things that happen, and we reproduce them. And just to give you some idea, this right here is a waveform of a sound that is occurring on the right side of a user's head. And just to kind of put that into a little bit more of an understandable position here, so this is the difference between the two waveforms for a sound that is coming from your right side. And you can notice that the one on the right side there, on the user's right side, which is your left, is a lot louder, significantly louder, but it does reach both ears. A little bit harder to see is that the sound also arrives slightly later, because sound actually travels pretty slowly compared to light, and so we actually do perceive the time difference between a sound arriving at one of our ears and then getting to the next one. And so that level difference and that time difference really gives us a really accurate left and right sense of where a sound is coming from. And because sound attenuates at a distance, we can also get distance, and that's also part of how we get that left-right difference between our ears. So that waveform being a little bit lower on the left side is actually just purely a function of the sound moving from your right ear to your left ear. Like, just that little bit of space provides enough of a difference in how loud that sound is that you actually can tell the difference between a left and right sound. But of course, like, again, sound doesn't just directly go straight into your ear. There are actually a lot more things that happen with that. They reflect off of your outer ear. So I've added just a couple, they're really a little bit hard to see here. But there are these reflections, actually. The sound bounces off of your outer ear, and in several different directions, and then enters your ear canal. And so what that does is that gives you a sense of elevation, because the different paths that that sound takes to get into your ear canal differs with several things, but one of them is the height that sound is at. And so just by, you can close your eyes and get a sense of where a sound is height just by, subconsciously understanding how those reflections are happening on your outer ear. And these reflections don't just happen to your ear, they also happen to the environment that you're in. And so if you imagine somebody whispering right next to your ear, then the sound will directly travel to your ear, but you'll also get reflections from, say, the floor. And so when the sound goes all the way down to the floor and then comes back up, you can see it's traveling a much longer path. And so that does a couple of things. It makes the sound a lot lower because it's traveled farther. It also delays it in time because it's traveling about twice the distance. It takes twice as long. So those reflections get to your ears after the initial sound. And it's also coming from a different direction. And so you get a lot of information from all these different reflections that are happening to the sound before it gets to your ear. And these are all things that we have, that we've modeled inside of our spatial sound processing. And of course, this is a super basic kind of illustration of it. It looks a little bit more like this. The reflections are happening all over the place, and this actually gives us a sense of the space that we're in. It's actually an interesting kind of test you can do yourself. If you walk into a room that you've never been in before, you can close your eyes and just either clap or talk. You'll actually get a sense of how big that space is. You might even get a sense of the shape of it and a lot of the materials that make it up. A room that has concrete floors is going to sound very different from a carpeted floor. You hear the differences in those reflections. Even if you don't consciously perceive them, you subconsciously perceive them, and you interpret all those things as being in a different acoustic space and being able to tell the difference between different sound locations. And the way that we measure this is with this really intimidating looking device. So this is Ivan Tashev, who's with Microsoft Research. And this is the chair. Has a little head strap and everything so that your head can't move. And what they do is they put tiny microphones inside of your ears. And then that little arc right there is actually an array of speakers. And so they play sounds from all different locations around you and measure the response that comes into those microphones. And each of those signals then gives us the model of how that person hears when a sound is coming from that particular direction. And so they sample, I believe it's something around 400 different locations in a complete sphere around the user. And we can process all of that and then create a filter based on that data that then reproduces it so that you can place a sound anywhere in virtual space around you, and we can model exactly what that is going to sound like to the user. Now there's a little bit of interesting differences between people's. If you've ever noticed, everybody's ear is actually a little bit different. So there is a degree of personalization that goes into that. And you can actually, it's a little difficult right now, but it is possible to get your own, they're called HRTFs for head-related transfer function. You can actually get your own personalized HRTF by kind of going through this process. I believe it takes about 5 minutes or something like that, so it's actually pretty quick. But by having your own personalized HRTF, it actually makes the spatial sound that much more accurate. We do a little bit of personalization on the HoloLens actually, which I'll get to a little bit later. So because we do this modeling in kind of a spherical array, we don't actually get distance directly from that. So partly what we do is we attenuate the sound based on the distance. So the farther away a sound is, the lower it's going to be. You're going to perceive it as sounding lower. But also, all of those reflections right, happen also in addition to the direct sound. So what you get is both the attenuation and then the reflections have their own attenuation based on these different room models that we have. So in spatial sound, whenever you use this, and I'll show you in the audio manager, there are 4 different room models that you can choose from to model different spaces. So you can actually, do a lot of different things with that. If you're going for more of a VR scenario, you can have your sound designer or anyone in charge of audio set what the room is, what the virtual room is that your user should be in, or you could even use the spatial mapping data to get an estimate of how large the user, how large the room the user is actually in, and set spatial sound to match that model. And that'll give you an even more accurate sense of that mixed reality sound, where your sounds are, being modeled in the most accurate way to where your user is actually located at that time. So we have a few really important benefits just in general that spatial sound provides to HoloLens apps. And the first one is it just grounds them in our real world, right? So we have this concept of world locking our holograms, right? So if I place an object right here, I can walk away, I can turn away, and it's going to stay right there. It knows where I'm looking relative to where that spot is, right? So we do the same thing with sound. We can ground a sound to this one location, and using all of this acoustic modeling that we have, we can really accurately convey the sound as being from that location. And so you can always hear a hologram, even if you can't see it. The other one is user attention. Again, going back to the idea of making HoloLens apps kind of more natural, more human, getting the user's attention through sound is a much more natural way to do it. I'm guessing, or at least I'm hoping, that when you try to get someone's attention, you don't kind of like put an arrow in their face and like direct them to where to look, right? Mm-hmm. That's not a natural human interaction that you would do. What you would do is just call their name, right? And they know where that sound came from, and so they can locate you that way. And so that just provides that really natural interaction. So you just play a sound at any location, and just as humans, we're drawn to just look in that direction, just naturally. It's not something you kind of have to explain to your user. And so using a lot of these kind of pre-programmed behaviors is one way to make these HoloLens apps really much more natural experiences, much more intuitive. The next one is immersion, which is like maybe kind of the most obvious, right? We want to just provide this kind of soundscape for your holograms, right? And if you're doing a more VR kind of scenario, you want a totally different room ambience and all this kind of stuff. And so by spatializing all of these sounds, even ambient sounds, you really get that greater depth of immersion from just making sure that everything has a particular location, right? 'Cause there are no sounds that, other than music that we listen to through headphones, everything is out in the real world, right? Everything is world locked. You can hear like that HVAC right now, and it's over here, and if I turn my head, it stays in that location. And so having these just general ambiences be spatialized just grounds them more in the real world, and it just kind of makes them more real, right? We're more convinced by all those sounds.
Can I ask a question?
Yeah.
On the immersion, if you have multiple sounds, do you do anything automatically to kind of get the composite sound of them interacting with each other, because that's what you're hearing in a large space?
Right. So we don't do anything automatically to kind of just composite multiple sounds. Each one has its own location because our HRTF algorithm is so precise. Even 1 degree of difference from sound can be spatially perceived. And so, I mean, there are definitely different ways that you could create ambiences that were a little bit more muddied in that sense. Maybe you don't want this really precise location, and that is something that I go into a little bit later. But in general, if you're spatializing sound, if you're using spatial sound or HRTF for it, then chances are you want that to be in this really, really precise location. So we don't do that automatically. There are different ways that there are different tricks that sound designers will do to kind of create a similar effect, though. So you can do that. But in general, your HRTS sounds are locked to a really, really precise location. And because we do all this really, intense physical modeling, you're only going to really you don't want to flood your user with just all these spatialized sounds, because you're not really going to be able to locate too many sounds at once anyway. So there are different kind of degrees of spatialization that you can actually apply to create similar effects. The last benefit right here is interaction design. So usually when you think of spatial sound, it's in these more kind of extreme cases of there's something behind you, right, and you need to just draw your attention back there. But even something as simple as a button or a menu that's directly in front of you still can benefit greatly from spatialization. So, we're used to these in a lot of kind of classic game design. We're used to these flat UIs, right, and we just play stereo sound because they're not these 3D objects that are in space, right? But on HoloLens, everything exists in 3D space. And so just having those sounds kind of grounded to a 3D object really provides, again, that much more natural interaction. A button sound that just gets played in stereo sounds like it's inside of your head. And on HoloLens, that's a really unnatural, weird experience, because we expect everything to be kind of out there and away from you. You give it a little bit of space. And it actually makes standard stereo sound seem a little claustrophobic, right? It's these speakers that are, an inch from your ears. And so providing that spatial sound processing on top of it just gives it a little bit of space, gives it some room to breathe, and makes it a lot more natural for your users. So this is a quote that we've used a lot for using spatial sound as far as interaction design, which is sound is touch at a distance, right? Any kind of impact of different materials and stuff like that, right? If you tap on an object, that's actually, those vibrations, the very same ones that you feel between your finger and a surface, are the same vibrations that are actually coming through the air to your ears. So there is a very, very distinct connection between those two things. And so we have this concept of kind of audio haptics, right, where we don't have haptic feedback for HoloLens, right? If you're doing a gesture, you don't get you get visual feedback from that, but you don't really get a tactile response from, a UI button or something like that. And so adding spatial sound on top of that to really reinforce all those interactions that your users do is really, really powerful for this. And so in our time making many different audio-focused HoloLens experiences, we've come up with some kind of best practices, at least best practices so far. One of the ones that we found is using real sounds. Real sounds work, in general, far better than synthesized or any unnatural sound. If you record something just from the real world, chances are it's going to spatialize really well. If you synthesize something that's kind of unnatural, like if you just have a pure sine wave, that's going to be a lot harder to locate that, because it's not a sound that we kind of hear in nature a lot. It's actually just, it's kind of doesn't have any of the properties that we really get out of, the acoustics in real space. And this leads to a really interesting small side. Maybe this is more interesting to me as an audio nerd, but I wanted to go over it a little bit. The reason that real sounds work better is because we actually learn how to locate sounds. We're not born with it. You're not born with just kind of, your ears are not locked in place, right? You actually just, over time, you've heard sounds in different locations, and you've seen where those locations are, and you've been able to just make those connections. You're not innately born with this. You actually just learn it over time. And so what that means is that you can, first of all, you can actually learn sounds. So if you do have, any kind of sound that your user has never heard before, over time, they actually will start to pick it up. And you actually will kind of just learn what the HRTF and HoloLens sounds like. And you'll learn what that sound spatialized is like. So you actually get, you actually will just learn over time. And all of these HRTFs are constantly updating. So for instance, when you were born as a small head person and you grew up to be a larger head person, your HRTFs completely changed during that time. You know, the distance between your ears changed, which is one of the biggest factors in how you perceive sound. Your outer ears change a little bit. You know, a lot of aspects of how you hear sound change over time, and this is why we just constantly adapt to that. So over time, you just constantly learned what sounds. You basically learn what your ears sound like, and so. And to kind of illustrate this a little bit, this is actually a study that was done. This diagonal line over in the leftmost box represents basically perfect spatial hearing. It means that you can hear sounds exactly where they're coming from in study, so you can kind of close your eyes. If we play a sound from one location, you know exactly where it is just based on the sound, right? And then they actually plugged up the subject's ears with kind of different molds for their outer ears, and you can see that in that middle box, the plot just goes crazy, right? You just lose all sense of space because your outer ears have changed. But then what they do is they train the subjects with these new ears, basically, and as you can see, after I think it's a few weeks or so of training, you actually just learn what those ears sound like. So you actually just redevelop your spatial perception of sounds. And so again, so you can learn new sounds, you can learn what the actual specific HRTF processing sounds like, and you can actually adapt to it. So there's a lot of times with any kind of UR test, or even just kind of initiating your user, if you're playing a sound that they're unfamiliar with, you can actually kind of just initiate, kind of train them a little bit, just very briefly, by playing it in a couple of different locations, and they just kind of, learn it just a little bit, and then as they go through your app, they'll just get better and better at locating that sound. But again, this is why real sounds work better. So if you can leverage at all, your user's kind of previous experience with sounds and use sounds that they already know that are just in the real world that they're familiar with, you can kind of really skip this part, skip the learning step, and just use really what they already know. A lot of these experiences that we've done are based off of trying to work with people's expectations and work with their previous experience to create the most natural experience. And this also goes to an interesting point about what I refer to as responsibility. So we know from Spider-Man that with great power that we have with this spatial sound comes great responsibility. Our sound is actually more real than the visuals, and it also produces a more visceral response in our users. And we learned this, and I know that Dave is here. I think he might know what story is coming. The first Holographic Academy course that we did, the first iteration of it, had these flowers that were around the user. And this cute little bee would come around and would pollinate the flowers. And so we thought this is really great, right? Because a bee, that's a real sound. People are familiar with this. And it can move around, right? And you can localize it anywhere. It's a constant sound, so they'll be able to hear it no matter where it goes. But one thing you learn with HoloLens apps is that you have no control over where your users go. And so a lot of people just started walking into the path of the bee. And as it turns out, hearing a bee flying toward your face is not like a pleasant experience for a lot of people. And so people would just start swatting in front of their face, and it produces this very, very real, very visceral effect in people with how accurate, with how real this spatial sound is. And so you really have to be careful with, kind of what you choose to spatialize. Unless you're making a horror game or something like that, I would stay away from bees. In general, don't use bees. So going back to this, we have real sounds. That was a whole aside, just coming from real sounds. This is a phrase that I like to use to explain the concept of bias for sounds. So expectation trumps simulation. So we have a simulation of spatial sound, right? So we know exactly what the actual kind of delta is between what a sound origin sounds like and how it arrives at your ears. But because sounds are learned, because you have all this previous experience with it, and that's how you spatialize sounds, that comes with some bias. So the example that I always use is we had this like audio showcase app. It's actually similar to a demo that I have here today. But what I did was I had this bird sound that would fly to different locations, and you'd have to find the bird and tap on it, and then it would move to another location. And so the first time it went kind of up to your left and above, kind of where you would imagine a bird to be. Then it would move over to the right side, but then it moved down and to the left, and everybody looked up. It didn't matter where you placed this bird, everybody looked up because they expect birds to be up in the trees or in the sky. You never hear a bird and just automatically assume that it's like on the sidewalk, right? So that expectation that people have is really just, it doesn't matter how accurately you can simulate the sound coming from a particular location. If the content has that degree of a bias, then your user is going to expect it to be from a particular location. It's not going to matter if it actually sounds like it's down below. If it's a bird, they're always going to look up. So you really want to, again, try to work with those biases and not try to work against them. In general, it's best to spatialize most of your sounds. So again, everything exists in 3D space. There's no 2D UI, there's no flat screen. Anything that you play in stereo kind of actually on HoloLens has a weird effect. We actually don't expect it too much, right? All these sounds are coming from the real world, and when we have these interactions that are more natural, that are in 3D space, we expect our sounds to be in 3D space. And so there are really very few scenarios where I would just recommend playing straight stereo. And interestingly, almost a little bit counter to that, but you want to avoid invisible emitters in general. And so, like, for instance, with an ambience, you can play ambient sounds spatialized, but you just want to be careful with them. You want to try to keep them a little bit farther away or something like that. If your user can accurately find the location of a sound and there's no object there, then it just kind of breaks their expectation. Again, like, we never hear sounds coming from nothing, right? All sounds come from some object. And so if you're trying to simulate things like ambiences, then you would either keep everything kind of far away or use some kind of spatialization that isn't as accurate as our spatial sound, because that means that your user is actually going to be able to just pinpoint the exact location, and it's a really weird experience and a weird unnatural experience. And avoid spatial masking. I don't know if that's a real term, I kind of made it up, but it sounds right. So, and what I'm talking about here is all those reflections and the acoustical cues that you pick up from spatial sound are really subtle in comparison to just like the direct sound, right? And so if you're playing 2D sounds, or if you have multiple sounds going on, you need to try and like adjust the level of those sounds so that they're not interfering with all those little acoustic cues that you get from placing sounds in your real world. So all those reflections and all the little things that you get, the subliminal cues, if you're playing ambiences or stereo music or anything like that, it's best to keep those things a little bit lower to give some space to your spatialized sounds.
Is there any automatic ducking available?
There's not automatic, but Unity's mixer does have the ability to do that, yeah. So if you assign things to different buses, you can automatically duck them, based on like, here's your ambience, duck it based on your spatialized sounds. You can totally do that, yeah. To bring that point home, again, like everything in HoloLens is in 3D space, so you definitely want to try to spatialize as many sounds as you can. and just make sure that that anything that is, again, coming from an object, whether it's UI, whether it's anything like that, especially if you interact with it. And one of the interesting things that we do with interactions is you can get the location of your user's hand. And so if you place an emitter at their hand, they actually get a sense of where their hand is in 3D space. And they get a sense of where their hand is in comparison to your holograms, which can actually provide that much more reinforcement. So the same way that we ground our holograms in a real world, you can actually kind of ground your user's hand in the virtual world. And that can provide some interesting interactions, yeah.
Can you describe that just in a little more detail? Like, what does the hand do to the sound?
So in the test that we've done, and it's one of the examples that I have in a demo today, what we do is we just play a looped sound. It's almost like a little bit of an ambient sound, and we just get the hand position data from HoloLens, which is pretty easy to do, using like HoloToolkit and all that stuff. And we play a looping sound and we spatialize it. And what I've even done some experiments with kind of exaggerating the angle that your hand moves. And so as your hand kind of moves off to one side, I actually place an emitter that is a little bit farther off in that location. So you get this really wide stereo effect, and you can tell where your hand is at any given time, and you really get a sense of, of interacting with this holographic world that way. So yeah, I definitely encourage you guys to check out the demos when we get to that. Yeah.
So going back to how you said interfaces should have sound effects to them, would you play the sound effect at the user's pinching location or at the UI's location? So with the typography thing, would you play it at the elevator or where he's pinching?
So most of the time, I would place it at the location of the object. Anything that you do at the user's hand, we generally use that for things just like kind of just understanding where your hand is and just being able to like provide extra reinforcement. But when it comes to actually the kind of replacing that tactile feedback and providing those interaction sounds like a button press or grabbing something, those sounds are usually best played at the location of the object that you're interacting with. Another interesting thing about spatial sound is that low frequency sounds don't spatialize as well as higher frequency sounds. And so in the case of a surround sound system, right, you have these 5 speakers that go all around you. You have one subwoofer, because guess what? When the dinosaur, stomps down on the ground, that sounds like it just comes from everywhere. You don't really have this really precise location for it. So you can, again, you can spatialize lower frequency sounds. You will get some effect from it, but it will not be to the same degree as like the mid and higher frequency sounds. And again, this goes a lot to just our training and our what we've learned. And so the most actually powerful thing to spatialize is the human voice, because that is the thing we are most used to listening to, evolutionarily speaking. It's the thing that is most important to us. And so if there's any kind of voice in any of your apps, that is the most accurate spatialization you'll get. And it's the most powerful thing that people really connect to. So especially in multi-user scenarios, if you have any kind of like networked experience where you have multiple people working in the same space, like there's a lot of that kind of educational apps that have a teacher in virtual space, and you can kind of walk around this 3D object with them. Spatializing that person's voice at that location also provides like that extra more natural experience, right? We expect to hear a person where they're standing, right? So if you have any visual representation of another person inside of your app, spatializing that voice is a really, really powerful way to reinforce that.
Have you guys found a best practice for what frequencies to roll off, like below, say, 400, 250, or?
Yeah, I mean, in general, so there's also a little bit of additional complication to that because of the speakers have their own response, right? And so kind of anything under about 300 is not going to be super relevant, right? But again, going back to the headphones thing, right? Like your user can plug in headphones, so you don't necessarily want to just roll those off. You know, you don't want to just get rid of them entirely because in different scenarios your users may actually hear that content. But in general, like the bass sounds, you're not going to get a lot of spatialization out of, and you won't get much response from the speakers in the first place. So they're kind of optimized for, you know, more close to that speech range of hearing. And the high frequencies will go up much higher, you know, like above 10 kilohertz or something like that. But yeah, so another concept for spatial sound that we've had is we call gaze mixing. And so this is the idea of kind of remixing all of your sounds based on where your user is looking. This is really useful not just in HoloLens, but even in VR applications. You can do this to really great effect. If you have the kind of more ambient sounds or just kind of noise that you're just using for immersive effect or something like that, but you want your user to focus on something, you actually know where they're looking because we have head tracking, right? So you can actually take that information and, you know, lower down the sounds that are behind the user so that they can focus on the sounds in front of them, or even vice versa. If there's something that's more important happening behind them, you can lower the sounds that are in front of them to really boost that sound behind them. So using head tracking, again, any kind of data that you can get about what your user is doing at any given time to try and more carefully direct them to like the experience that you want them to have. Head tracking is, you know, one of the great ways to do that, and making sure your audio kind of coincides with that well and works with, you know, the direction that you want your users to look and all kinds of things like that. So, you know, remixing your sounds based on your user's gaze is actually a really good way to kind of filter out a lot of the noise and really allow them to focus. One interesting thing that came up kind of recently is the idea of compression. So, you know, especially in something like Unity, it will take all of your audio files and will compress them to an OGG Vorbis format by default, and you can set a quality setting on that. And so this is, you know, kind of just the digital representation of a sound wave, and the more points that you have along here, the more accurate that your sound is, right? And the way that compression works is by something called perceptual encoding. Basically what it does is it removes information that you're not going to hear. And what the thing though with that is that it's optimized for just kind of stereo playback. So if this sound, you know, if there are two frequencies in the sound that are really close together and one of them's a little bit louder, it will actually remove the information for the lower frequency. And so, which in general is not a problem because the idea is that you don't hear that anyway. But with spatialization, because that does a lot of filtering and a lot of processing, you actually want to be careful with your compression because that can actually affect the frequencies that your sound actually plays back. And so whenever you change kind of compression settings for your audio, it's best to make sure you listen to them again, spatialize to make sure that they are still accurately spatializing.
So are there any tools that we can use or any software we could run at runtime with this thing that could help us pinpoint the source of a sound from the environment?
To pinpoint the source of a sound, so are you talking about, so when you're in the experience, how do you like know where a sound is coming from, or what?
Yeah, right. Like you know, somebody's wearing it, watching something, and a sound event happens over here. It'd be nice if the software knew where it was. We could get spatial information from that at runtime.
Well, you absolutely do get the location. For instance, if it's in a Unity app, for instance, every sound is playing from a game object, so you always have positional information.
No, I mean
on
from the
sound.
actual environment. You know, something happened in the real world.
Oh, I see.
We could use the microphones on this thing. Maybe volume differences and phase differences to position it somewhere. Have you done that?
So you can. I mean, you can't reposition it, right? Like, so there is a degree to which you can detect the left and right difference for the microphones. We don't have anything that does that automatically, but using going back to the microphone streams that we have, we have a room capture stream, which is a stereo stream. So there are two microphones on the outside of the device. And by capturing that information, you get a stereo stream of the world, which provides you with a left and right difference. The microphones are omnidirectional, so which means they just take sound from all different locations equally. So you don't get any kind of back to front data like that, but you can get the time and level difference between the left and right. So you can't super accurately place the sound like that, but you can get at least some idea of like pointing the user in the right direction, for instance, like between left and right. So you can get that data.
I had a problem. I'd be wondering like the same thing, like does HoloLens filter only the voice command come from, you know, you can locate the sound like in the middle of the microphone, not like a far left, or so like if somebody else say the same thing, select the place. If HoloLens filter that, like only your voice.
So again, going back to those microphone streams, the speech capture stream is beamformed to the user's mouth, so it will filter out anything from the outside. Not perfectly, but basically your voice commands are going to come in way clearer and way louder than anyone else's, unless they're, you know, they could be standing right next to you or something like that. But in general, the room is completely isolated from the voice capture on the device. But you can switch between these streams so that you can actually capture the room and get that, you know, you could take a person's voice who's not wearing the device, right? You can actually kind of record their voice separately from the stream that's doing the user's voice capture. So it is isolated. Those are two very separate streams, and you can use them independently. One of the things that I get questions on a lot of times is the concept of binaural recording, which if you've never experienced this, it's pretty cool. The most famous one is I think the barber shop, where you can put headphones on and go through this kind of virtual audio experience of being at a barber shop, and you really hear the the buzzer and the scissors, like, you know, cutting right around your ears, and it's actually kind of unnerving. A lot of people just kind of move a little bit or kind of swat, because again, it provides that really visceral reaction. And so binaural recordings are really great for headphones. They actually don't work as well for HoloLens because we have head tracking, and the moment that you turn your head, that whole binaural effect is completely lost because these sounds are locked to the user's head rather than being locked to the world. And so the second that if you have like the barber is buzzing right near your right ear and you turn, you would expect them to be behind you, but they actually kind of just stay right there no matter what you do. You can't shake them off. So so binaural recordings are really locked to this like one really precise location. You don't get the dynamicism of having objects that are world locked out in your environment. It's really just a headphone experience. It's not anything that uses head tracking or anything like that. So it's a cool effect, but you won't get the same degree of kind of realism that you will get from placing individual sounds and using spatial sound with that. Okay, so then we go into just the concept of just mixing. So once you have your spatial sounds in your experience, kind of really managing how all those things sound. And this is a quote that I actually stole from one of our audio directors who is now at Xbox. Came up with this, I really like this saying, you can't mix for the stationary person. So if you are listening to your experience in just a single location, then you are not really experiencing the variety of ways that your user can experience this. Like going back to the bee example, when we initially made that experience, we stood in the middle of all these flowers and the spatialization worked great and nobody had any problems. But the second that, we were actually doing playtesting with this with people who are unfamiliar with it, all of a sudden, spoilers, all of a sudden, they were walking in different places than we expected them to, and that provided a really different experience. And so you really have to walk around the entire environment that your user's in to get an idea of how they're going to experience your sounds. Another one is the environment really matters. And that's in terms of if you're demoing or just accounting for just the different environments that your user is going to be in. You may notice that if you've done demos here or in kind of other events, and there's a lot of people talking around, and it gets pretty noisy, and it gets actually really difficult to hear just the experience. And similarly, you know, if you're standing next to someone who's going through an experience that has audio in it, you can a lot of times hear their experience. So it really matters like what environment you test this out in. So you may want, so what you want to do in general is just try it in a noisy room, try your experience in a quiet room, and make sure that you are accounting for the different, you know, for the variety of environments that your user can be in, because it can change your mix pretty drastically, yeah.
When you start recording those sounds, is there an optimal box or sphere that you would position those sounds at as a default starting point?
When you initially put your sounds inside of the experience, I mean, it's best to start, like, again, going back to the avoiding invisible emitters, like you really, all of your sounds are generally going to be, you know, placed, you know, wherever the actual visual representation of that object is. But as far as kind of optimal locations, although we do model the different elevation differences, we're actually just, as humans, we're actually not that great at it because it relies on these reflections from our outer ears. We don't spatialize that quite to the degree that we spatialize laterally. So left and right changes are much more apparent than height changes or even back to front changes.
So like you started building this app in your office, you're in a cube that's 10 by 10 by 12 or something, right? And
Yeah.
Here, you got a much different room.
Yeah.
Do I need to allow for that and like kick off my debt?
Yeah, I mean, certainly depending on you know what the experience is and kind of what space it's made to be in. The important thing, the size of the space is actually not even quite as important as just the kind of acoustic properties of the space, whether that is the materials of the space. So if it's in just like a parking garage that's really reverberant, that'll definitely affect it a lot more. Or if there's just loud ventilation, right? Like we did a lot of tests where we go into just different rooms, and you know, you can have this experience that sounds great when it's in, you know, kind of a controlled, quiet environment, but the second that you go into an office where there's like a loud HVAC, it can just totally throw off what you're hearing. So you just want to make sure that you test for that and kind of just provide the kind of like middle ground where it's just going to be usable in a variety of scenarios. There's also, if you want to like really go farther with it, you can even provide some degree of user control over just like how loud your sounds are, so you can kind of compress them a little bit more. You can use the Unity busing system to do that. Or, you know, you can use the microphones to find out what the noise level is in that environment and adjust accordingly. So there's like, again, any kind of data that you can get from the user or just from the environment on the device, really effective to use for to adjust your sounds accordingly. And kind of going along very similar lines, you want to target the 70% volume, which is the default for the device. If you make sure that your sounds all come through clearly but aren't too loud for most users at 70% volume, you're going to be in a really good place to make sure that, for instance, when someone's in a noisier environment, they have a little bit of headroom to bump it up. Or maybe they just have some hearing loss, right? Like everyone kind of hears just at slightly different volumes. So you definitely want to keep a little bit of headroom for somebody to turn it up in different scenarios or for different users. And so 70% is a really good place where it's, you know, the volume is most of the way up, but it's not completely maxed out. You want to just provide that extra little bit of space for them. And going back to the, this probably looks really random, going back to the idea of kind of remixing, a really good example to use, I couldn't actually find a screenshot of the actual setting page, which is really frustrating. But Battlefield 4 does an interesting thing with their audio where they actually have these different mix settings. The kind of most famous one is called War Tapes. And what they do is they put a dynamic compressor on all of the sounds, and they play everything a lot louder. And what that does is, I mean, partly it gives this effect of kind of older recordings, right? So it's just kind of like an immersive aspect to it. But in addition to that, when everything is dynamically compressed a whole lot, that actually allows the user to turn down the volume but be able to hear everything kind of evenly. And you want to be a little bit careful with this in HoloLens because you don't want to compress too much because it can affect the spatialization, and especially when it comes to distance. But just providing a little bit of either user control or automatic control, again, with the microphones, providing just a little bit of different dynamics to your sounds can really give you a lot more flexibility in the situations in which your app can be used. So again, with the environment, it's really important to know that, like, in addition to just hearing your app, you're also going to be able to hear the real world, and we want to make sure that all of your sounds are loud enough that you can spatialize them, but you also want to be able to hear the real world. I'm sure some people at least have had this experience with demoing. If you are demoing a loud app on HoloLens, even though it's not occluding their ears, even though they can still hear most things out in the real world, if there's like really loud music playing or something like that, you'll get that effect where, just somebody, you try to communicate with somebody that you're demoing to, and they just start shouting their response to you because they have this just different perception of the room environment. So again, just keeping in mind the fact that it's kind of a mixed reality situation, so you want to provide a little bit more breathing room in terms of your sounds. You don't want to constantly be barraging your user with sounds, but you also want to make sure that your spatialized sounds, again, have that little bit of room to breathe, have a little bit of room for all those reflections and the little subtle cues that happen with spatial sound. And just one of the cooler kind of bonus features that I like to try and get into are the different apps that we've done. If anybody has seen the video of HoloLens when they have this little Minecraft scene where they put dynamite on the wall and blow up a hole, and then there's this other world. Again, using the microphones, one of the really cool things that we've done in some of the demos before has been what we call user verb, because we couldn't think of a better name. But basically what it is we take that voice stream from the device, we actually process it through a reverb and then play it back to the user. So imagine a scenario like this where you have this other world, you have this really like large cave or something like that. You can actually have a user kind of shout into it and have it echo back to them, right? And again, like that kind of provides that extra level of immersion, right? And there's a lot of like interesting combinations of using the microphone along with the speakers and a lot of the processing. And also, you can take that sound, that stream from the user's voice, and you can spatialize it to that location. So not only are they hearing just the general echo, but they actually can locate where that echo is coming from, which can be really powerful. One of the other areas that is really useful for sound is in accessibility, right? So this is one thing that came up at the VR hackathon that we did recently in Seattle, which was there was actually someone that was going around kind of doing this kind of little check on how accessible all the different apps were. And so a lot of that goes into audio. Like again, with the idea of just being able to locate sounds, objects just through sounds, right? Like people kind of have different visual acuities. You don't want to be putting too much stuff in their face. And so just kind of really clearing up a lot of the visuals, you can use sound to direct your user's attention, or just do kind of text-to-speech that you are reading off all the things. And even something like text-to-speech can benefit from spatialization, right? Because you can actually be reading it at the location that sound, that the menu or whatever it is, wherever that text is located in 3D space, you can actually spatialize that synthesized speech as well. And that gives your user a lot more information about kind of the layout of your your holograms and your experience. and also, of course, using voice commands as a replacement for gestures. So it's not directly, you don't need to do a lot you don't need to actually take the microphone stream, there's a really easy API, especially, using the Holo Toolkit stuff. You can really quickly just put a voice command in your application to replace gestures that maybe people can't do as well. So there's a lot of audio in accessibility possibilities there. And touching on this concept of personalization, everyone's ears are a little bit different. Everyone's head is a little bit different. And so everyone hears slightly differently, right? So there's just everybody is just going to be hearing at, there's not one model that just everybody hears at exactly the same way. And again, because it's all learned, and it's learned based on your ears, everybody's going to be hearing a little bit differently. So there is a kind of push to get more personalized HRTFs out of spatial sound. We actually do personalize the HoloLens spatial sound by the calibration that you do actually estimates the distance between your eyes, and based on all of the data that we have gathered for people's IPD, the interpupillary distance that we measure with that calibration step, we can estimate the distance between your ears. And that is one of the key components to how you actually hear sounds spatially. So we can actually provide an extra level of personalization on top of just the general spatialization that we do for the individual user, which just gives you that much more of an accurate simulation. And there are other little fun tricks that you can do. One thing that you kind of get for free in Unity is this concept of Doppler, and we can test out how the stereo sound is working here with this, hopefully. Right? So you hear that pitch change, that volume change between the two sides, and that gives you a real sense of the speed of an object, right? And Unity will do a lot of this calculation for you, and you can kind of adjust the scaling that happens, right? It's going to try to estimate what the most realistic Doppler effect is, but you can change, if things are kind of, if the Doppler effect is a little bit too extreme sounding for your app, you can change that setting globally or on individual sound sources. So if you have a sound that's going really fast, but you don't necessarily want this crazy change in pitch, you can actually adjust the effect of that. And the other one is occlusion, which is basically anything that is blocking a sound source. So if there is, there's a hologram that is blocking another hologram that's making sound, it's going to kind of come at, naturally, if that happens in the real world, that sound's going to be a little bit muffled. You're going to be able to hear it. It's going to be low frequencies and stuff like that. If you've ever heard, music coming from another room, you pretty much only hear the bass, right? Then when you open a door, you get that kind of full spectrum of the sound. And so we can use this concept of occlusion by putting low-pass filters on sound sources, and so that when they're blocked, you can actually kind of provide that extra detail of providing this muffled sound for objects that are behind other objects. And one of the really cool things for HoloLens is that because HoloLens is always mapping your real world, you can have holograms be occluded by the real world in sound as well as visually. So I know that that's a thing that happens in the Holographic Academy. We do, the test on kind of visually occluding objects, and you can do the same thing with sound. And it's a really, really powerful way to, again, get more information kind of packed into these sounds. So you get location, and you get the distance of it, and you can also get just whether or not it's behind another object, which provides that extra level of depth. And I duplicated that. Oh, right. So again, live voice. So if you are doing any kind of multi-user scenario, just taking the live voice from the networked people and spatializing that. Again, human voice is just the most powerful thing to spatialize. It's the thing that we have the greatest connection to. I could go for an entire talk on just how important voice is just to us in general. And so anytime that you can spatialize any kind of voice, whether it's live or just any kind of VO that you have, that's a really, really powerful way. It's really accurate that we know those exact locations. And there's an audio phenomenon known as the cocktail party effect, which if you're not familiar with it, it's the idea that you can be in this loud environment with all these different conversations going on, and you can kind of focus and just zoom in on this one single sound, right? And so part of that is the spatialization between those sounds. So you can kind of slightly turn your head, and you can kind of really orient yourself to best be able to hear these really specific locations, even through all the noise. And so it's kind of similar actually to the concept of gaze mixing, right? We kind of do that for you. So you can kind of give your users almost like audio superpowers, right? To be able to hear something that's really far away and kind of just zoom in on it. So I've given you kind of a lot of theory, a lot of just ideas for sounds and stuff like that, and how to implement them in HoloLens. But for a bit of practical knowledge, if anyone is not already aware, the way that you get this the Microsoft spatial sound in Unity is through the audio setting in your project settings. So you go to project settings and audio. There's a drop down. This used to be exclusive to the HoloLens technical preview branch of Unity, but as of the 5.5 beta, it is accessible in just the main branch of Unity. So you can always select the MS-HRTF spatializer. Now, that doesn't automatically just spatialize all of your sounds. There's an extra layer to that, which is on the audio source itself. So when you select a spatializer from that drop-down in the settings, you get this extra little spatialize checkbox, which is the third checkbox down there. And by checking that, you basically override the standard Unity 3 spatialization with the Microsoft HRTF solution. So that's what gives you that extra depth and that extra degree of accuracy in your spatial sounds.
To be clear, you said the third checkbox down. Can you clarify?
Yes. So there are a couple of settings on here. The first one is just your audio clip and your output. There are multiple checkboxes just to kind of spread down through there. It's at the second. Okay, I was just looking at it at a weird angle, and it looked like the third. It's actually the second. Thank you. So after mute is the spatialize. If you don't set your spatializer, that checkbox just will not exist. It will go from mute to just to the bypass effects. And so that's a really good way to test. To just add an audio source or something, and you'll be able to tell whether or not you have the spatializer selected.
Can you go to the previous slide real quick?
Yeah. And I can post these slides as well if it's useful for people. So once you have the spatializer set, we have this great little tool in the Holo Toolkit called the UAudio Manager, which began as just this little script that I wrote internally for us to use when we didn't want to adopt this giant middleware for just our little kind of prototype projects. And so it handles a lot of that. And actually our buddy Dave back there kind of adopted it and kind of put it into the Holo Toolkit in its current form. And so it's been a great team effort to try and get spatial sound a lot more accessible to people. And actually, and I don't know how we're doing on time. I plan to do a little bit of a live demo. We can maybe just run through that real quick. So if you are not using Unity and you're very brave or just a glutton for punishment maybe, we have a much lower level API for spatial sound with DirectX. So you can get access to all of the same stuff. You can get the room models and all these kinds of things through the C++ API. So you can integrate it into any existing audio engine or using your own audio engine. And so this is just a flexible solution. You can kind of add a plugin to anything that you need. And so just an interesting point to bring up, especially in light of the creators update and all kinds of things that are going on just in Windows in general, is that spatial sound is not specific to the HoloLens. It was adopted, it was the first adopter of the technology, but spatial sound exists in Windows 10 all up. And so any Windows 10 device can use spatial sound, whether it's a desktop, HoloLens, or a mobile device or anything like that. It's all accessible inside of Windows 10, which is also what allows you to use it inside of Unity. That Unity plugin is just hooking up to the Windows 10 API, which is actually really important. I assume that most people who are developing on HoloLens are doing so on Windows 10. But if you're not, you won't get that spatial sound plugin. It'll just kind of fall back to the Unity spatialization. But you can create any Windows 10 app and use spatial sound with it. And so, really quick, just to prove that I'm, to prove the Unity stuff, I want to just show you a little bit of how the Audio Manager works. Has anyone used the Audio Manager here at all? Okay, cool. Fresh blood then. This is great. You'll actually learn something, and I won't be telling you stuff that you already know. So I created just this blank project that just has a couple of audio clips in it and just a couple of really simple scripts. And so just to prove that I'm not cheating, I'm just going to create a brand new scene and create this empty game object. And so the Audio Manager, there we go. So the Audio Manager is a script that you can add to just any object. It acts as a singleton, so you just need one instance of it anywhere in your scene. It could be a prefab that you drop in at some point, or you could just put it on one of the objects in your hierarchy. As long as one of these things exists, then you can use it to play spatial sounds on any game object in your scene. And so by default, you kind of have nothing going on here, right? So all you have to do is add an event, and then we get all of this information for the different things that we're able to do with sound events here. So I'm just going to very uncreatively call this event test. And so we have our positioning here. So you can play this just in standard stereo. You can play it in 3D, which just uses Unity's default spatialization, or you can use spatial sound. And by using spatial sound, that's what gives us access to things like the room size, which is our 4 different room models that we have. So again, you can match the user's room. You can create kind of your idea of this virtual room and have different sizes for those spaces. And the minimum gain and maximum gain, which kind of control just how much your sound can attenuate. So the maximum gain can boost the sound up to a certain level. The maximum is 12 decibels. So as your sound gets closer to you, you can boost it by up to 12 decibels above Unity gain, which in general, if you're normalizing your sounds, you probably want to just keep it at 0, but there's a little bit room to boost if you need it for any reason. And then minimum gain is just as the sound moves away, it's going to get lower and lower to a certain point, and you can actually kind of clamp that off to say that you never want to get, say, below negative 20 decibels, so that no matter how far your sound goes, it'll always be audible at whatever distance. And so that is a good trick to kind of do if you need a sound that's like really far off for some reason. Most HoloLens experiences, you're probably not putting things several miles away, but in case you are, you can always use that to make sure that your sounds are audible from those locations. And Unity gain distance is in meters, and that's the distance at which you're hearing the sound just as it's normally authored. So if you were to just listen to the sound through your speakers, then at 1 meter, that's how loud that sound is going to be. So that's a good way to kind of configure the level of your sounds ahead of time, and get an idea at least of what it sounds like. There are a lot of things here that I'll get into in a second, but I really want to just show you kind of what, in general, this manager does. So I'm going to add some of these sound clips in here. Actually, I should just start off with one. Let's remove that. So I have another script that I wrote just for helping me out with this, which is the audio tester. And it's really simple. Basically, this is just to show you the interface for the audio manager. So again, it's a singleton, so it's just using the instance of it. So you just call it on uAudioManager.instance, and you call this function called playEvent, and you can call that on any object. So by default, you can actually just not call this on any object whatsoever. You can just say, I want to play the event that's called test. And so now that we have our sound, let Unity compile there for a second. So then we can test out our sound. There we go. So we have this one-off of just kind of like a cement impact sound, right? Now, one of the things that will immediately get apparent is that if you just have this one sound, you're just playing it over and over again, it gets really fatiguing. You're hearing the exact same thing, and our ears are really sensitive to minute changes in sounds. And so when it hears the exact same thing over and over again, it gets really fatiguing. So one of the things that you can do to help out with that is just add multiple sounds. And so you get a little bit of variety that way. And the audio manager will do all the logic for you to randomly choose a sound, and it adds the audio component, the audio source component, and it'll set all the properties that you need. And so by just creating this random container here with these 3 different sounds, now each time I play the sound, you get a little bit of variety in there. It's not the exact same thing every time. We get a little kind of subtle differences in there. But even that, a lot of times is not quite enough. You can start putting 50 sounds in there, it just gets a little ridiculous. So one of the things, one of the little tricks that sound designers often do is they randomize the pitch every time, so you get a little bit of variety in just not only the audio clip that you're playing, but the pitch that it's playing at. And so we keep our pitch center just at 1, which is just the default. It's going to play at the exact pitch it was authored at. We don't have the randomization here. It looks like that was removed. Dave, did you remove this? The randomization for this? So, in theory, after we get Dave to fix this, you can also randomize volume, pitch, and all this kind of stuff to... Oh, yeah. This is open source. You can do it all you want. I mean, I already added it, but I guess I can do it again. So randomizing the pitch, randomizing volume, a lot of these little subtle changes that you can do to these sounds just to give it a little bit more variety. And again, it's all handled inside of the audio manager. So it sets all those properties, it randomly chooses a clip, it kind of does all that logic for you so that you don't have to repeatedly create these arrays of sound clips and generate a random number to play them. And so putting a different sound in here, we can remove these other ones and go back to that lovely bass track that we heard earlier and play it in spatial sound this time. So what this does is this will now play our sound through HRTF at this location. So let's see, like this. And we can move it around. Now obviously we're playing it from speakers here instead of headphones, so you don't get the exact effect, but it's also a great example of one thing I forgot, which is you can also loop the clips. So if a sound is meant to be seamlessly looped, like this is just a looping bass track, you can really easily just check that box and then have it just seamlessly play that clip repeatedly until you stop it. So then just by using that spatial sound now, we actually get this effect, you know, as we move it closer, it gets louder, and we can move it all around. And although you won't maybe get the exact, you know, effect of it being behind you in this case because the speakers are in front of you, you definitely get really that sense of, you know, especially its distance, right? You get a much better sense of the distance just from that attenuation and the little bit of details in the reflections and things like that. And again, because this you can just keep moving farther and farther away. And just the farther away you go, this is actually an exponential kind of decay. So it decays really fast right away, but then as you go out, it kind of levels off a little bit. And so that's what allows you to hear sounds from very, very far away. Yeah.
So is it playing from the U audio manager because you did not hit a game object?
I'm so glad you asked. Yes, it is. So the way that this works is if you just call just the event, by default, it just plays it on the audio manager, which is, you know, maybe not what you want. The reason that exists is mostly for 2D sounds. If you don't actually care about which game object it's playing on, you can just play it on the audio manager just as like a standard stereo sound. But if you want to play it at a particular location, this will play it on the object I have this script attached to, which is a different object. So we have our audio manager here, but this is my audio tester, actually. And so this one will now be, if I play this here, we can see that now going to our audio manager, hit this, and we have this kind of little relic audio source that we do as a trick just to initialize the HRTS system. But the sound that's actually playing is now on this object here. And so we can move this one now independently. And so a really quick way to just get spatialized sounds inside of your experience, you just really quick, like one line API to just play a spatialized sound on anything. You can have this totally different authoring environment to have like a sound designer just go in here, add their clips, set all their properties, and do everything they need to do. And because you're just calling it through this event, they can completely change the sound, and it doesn't change any of your code. You can just totally isolate the actual sound event from what's actually happening in it. So they can swap out clips, they can swap out all the properties, and you're just calling the same event, so it doesn't change anything for the developer. So that's actually pretty much all that we have. We have demos if anyone wants to check those out. And thank you. Yeah. Oh yes, thank you. So yeah. Yeah, so all that muffling that I talked about, and that description of just having objects hidden behind other objects and having that muffled sound, Dave actually added that very recently into the Holo Toolkit, so you can add scripts to the sounds that you want to include, to the objects that you want to include sound, and they'll kind of behave more physically accurate. So it's really, really awesome work. I highly suggest everyone check that out. And yeah, thank you so much.
I'm going to ask anybody that has questions, if you could ask them into the mic. Also, if there are any questions online, I think this is our first meeting where we're successfully really live streaming, so we might have some live viewers on that might have some questions as well.
Cool.
And while that's going on, I'm just going to switch over and get some slides set up for the draw, so we're going to do. Not sure about feedback of this mic in front of the speakers, so I might ask you to come up to ask the questions if you don't mind.
Testing 1, 2.
Yeah, make sure you're not blowing it up.
Test.
We all good then? Do we want to do demos and stuff? Like, forget questions. Let's just play with it, right?
We got one question for you. Yoon? For your app, do you plan on updating the spatial mapping instead of just being like kind of standard spatial mapping to doing more of a spatial understanding?
I hope so. Looking into the Time Finder in HoloLens, but obviously it's not that stable different. Obviously, I want to explore spatial understanding, protecting types of those kind of space. That would be awesome.
Okay, perfect. Any other questions?
Did they hear that? Because I was by the quiet and I'm right next to them.
Yeah, I'll write it down online as well.
Okay.
Anybody else?
Well, that presentation and all the presentations were real gold this week. So great, thank you, everybody. In order to bring this to you, it has a lot to do with our sponsors. One of the things you may want to look into now that you're members of WinHUGR is there's a member-only page that has a few of the special discount codes that are available only online. So if you haven't checked that portion of the site out, please take a peek. Two major publishers provide us pretty significant discounts on both ebooks and physical books if you happen to be in the market for those. And here's a quick list of those folks that are supporting us. Mentioned very quickly, Unity is a major sponsor. Microsoft HoloLens team supports us with demo devices. Orange Studios, the place that you're sitting in tonight, is a great co-op space that also you can get coupon codes to come in and try the space for a day if you want to take and find out if this might be a useful workspace for you to integrate into your business plans. Route 3 provides the pizza, which you've probably been smelling for a little while out back. Leap Motion, Wiley, Manning, Pearson, and all provide us door prizes. And Indigo Slate has provided us a bit of support in some of the efforts we've done in other areas. They're kind of a promo sponsor for us. So getting right over to the door prizes, I'll grab those. You look like you have a question.
I was just asking if you wanted to cut the feed.
Yeah, I don't think there's any need for the guys at home since they didn't get tickets. As we do each month, I'll ask that anybody who wins the door prize, please come up and find the door prize on the list and just give us your specifics of name, email.